So we are on page 4 of this geometry refresher, and Pythagorean theorem is something that you learned last year in Math 1. The formula for the Pythagorean theorem, or the Pythagorean equation, is a squared plus b squared equals c squared. And that is, we have one of our legs, when we square it and we add it to the other leg squared, we get the hypotenuse squared. Now, in order to use this formula, you have to ensure that you have a right triangle. So it can only work if you have that 90-degree angle. In number 40, 41, and 42, we have to find the missing piece of this triangle. And in number 40, they give us two legs, so if we put it into the formula, we know that this missing side would be our hypotenuse, or we can name it C. So if we take 21 squared plus 20 squared, it will equal c squared, hypotenuse squared. Well, putting this into the calculator, squaring those sums, okay, we get 841 equals c squared. Taking the square root of both sides, we have to make sure that our answer is appropriate. So in semester 1, whenever we were introducing a square root, we always had to account for a positive and negative answer. But since we're talking about a length, a real life length, we will only use a positive answer, because a positive answer, a length, only makes sense. So if I put this in the calculator, I get 29 to be c. So the length of my hypotenuse is 29 units. Now 41 is saying that we have a right triangle that has a hypotenuse of length 25 and a leg of length 10. Find the length of the other leg. It might help to draw a figure with a right angle, because we know it's a right triangle. It says the hypotenuse is 25 and one of the legs is 10. We have to find the missing leg. Maybe I'll name it B as another leg. Maybe I'll name it X. It doesn't matter what variable you choose. But we would put it into the formula. 10 squared plus b squared equals 25 squared. Finding out some of these values, 25 squared gives us 625. 10 squared is, of course, 100. Solving for b, because we have to find the length of b, we get b squared to be 525. Now, if you put this in the calculator, you will get an approximation. So let's practice having an exact and an approximate answer. We might have to use a factor tree for this one. Okay. Finding numbers that go into 525. I know if I divide by 5, I'll get 105 for the other factor. If I break it down and I divide by 5 again, I'll get 5 times 21. Okay. Well, 21 breaks into factors that won't become pairs. So if we were to take the square root of both sides, an exact answer that we would get, matching up the pairs and the leftovers stay underneath the radical, we'd get 5 times the radical 21. But an approximate answer, because we want to know like an approximate length, if we put this in the calculator, round it to the nearest hundredth, 2 decimals, we'll get 22.91 units. So both of those answers are fine. It just depends on the context of the question and what the directions say. Now, you guys did last year in Math 1 a lot of different reflections, rotations, and you might have been comfortable using the patty paper. Perhaps you like using it a lot. So I'm going to show you using patty paper. Of course, there are multiple methods to use and find these features, but we're going to be talking about reflections. Okay, reflections just mean that you're flipping across something, and they want us to find the reflection across x equals -2. Well, this is the x-axis. The line x equals -2 is right here. It's this dotted line that I'm drawing in. Okay, so what we can do with the patty paper is we can actually, for this one, I guess you could use the patty paper. I might actually, for this one, just reflect the points. Maybe when we get into rotations, it would be easier to use the patty paper. But we're just going to reflect each point across this line, meaning that the amount of units that it is left or right of it, it will be on the opposite side. So this point E is 1 to the left of this line. So E prime, I'm going to call it. Prime is like that little almost apostrophe mark, is just saying it's the second version. It's after you complete the transformation. Z right here is 2 to the right, so its transformation will be 2 to the left. I'll mark it as Z prime. And then last but not least, K is 1, 2, 3 units to the right, so it'll be 1, 2, 3 units to the left. And I'll mark it as K prime. Of course, this was a triangle before, so you're going to want to connect these points, preferably with a straight edge, to form your new triangle. Number 44, reflection. Again, you're flipping across y equals 1. So this is going to be a horizontal line. Y equals 1 is right here. Again, K is 1 above, so the transformation will make it 1 below. This point right here, I, is 1, 2, 3 above, so it'll be 1, 2, 3 below, I prime. And then A is 2 above, so it'll be 1, 2, 2 above, 2 below, as A prime. Connect. And now you have your reflection. Now, I was talking about patty paper before. Remember, patty paper was this paper like this, okay? Almost like wax paper, little strips that you pick up your donuts with. Number 45 is saying a rotation at 90 degrees counterclockwise, so the opposite way of a clock. So we're going to be going this way. 90 degrees, okay, about the origin. That's the point 0, 0. So what I would do with the patty paper is you put it over the region, and I would trace my original. Pencil usually works best. And I would also write the letters of this figure so that you can keep track where the new points are located. Now, we're reflecting about the origin, which is at 0, 0. I like to make a reference line right here to know how many times I actually turned this paper. And it says, again, counterclockwise, so we're going to the left. So I'm going to move this triangle and rotate it 1 turn so that this line, this reference line, is now on this x-axis, okay, between quadrants 2 and quadrant 3. Okay. Now my new points I'm going to mark on the paper. I'm going to just peel it away. So I know that my x is going to be right here, and I'm going to label it as x prime. My b underneath, b prime, and then s is right here, s prime. Okay. I connect, and I have my transformation. And then the next one is rotation 180 degrees about the origin. So it doesn't matter, since it's 180 degrees, this is 2 turns. It doesn't matter which way you go, because it'll give you the same, it'll put it in the same place. So I'm going to trace again. Okay. I have my points, V, N, this is X, and J. And again, I make my reference line so I know how many turns I've made. So 1 turn, 2 turns. Okay. I'm going to label this for the points Y. This will be V prime, N prime, J prime, and then X prime. I connect to make that trapezoid, and that's my transformation. So the patty paper to me is the easiest way. You might have learned with different rules or patterns last year, so you're free to use whichever method works for you.